Hi everyone, my name is Anastasia, or you can call me Stacy. Hope everyone is doing great and ready for a new portion of knowledge. So in that presentation, my main goal is actually to raise awareness of using IPv6. And that's why I want to talk about it from cybersecurity perspective. So first, a bit about me. I graduated university in on 2019. Now I have a master's degree on informational system security. In general, I've been working in IT for 2.5 years, half of which I'm in cybersecurity. And now I've been working as a security analyst in the SOC team. So today I'm going to cover a bit of IPv6 introduction, types of IPv6 addresses, implementing of IPv6 at your own environment, and also network reconnaissance in IPv6 networks. Let's start with that. Every device that uses the internet is identified through its own IP address in order for internet communication to work. So basically, it's just like the street addresses and zip codes you need to know in order to send a letter. IPv6 is the latest version of the Internet Protocol, and the version we are all familiar with more is IPv4. The key difference between the versions of the protocol is that IPv6 has significantly more address space. And as you can see, addresses do look the same as well. The IPv6 has 128-bit addressing scheme, and that means that it consists of 8 groups of 4 hexadecimal digits with the groups separated by colons. And for comparison, the IPv4 has 32-bit addressing scheme. So it consists of 4 groups of decimal digits with the groups separated by dots. The expanded addressing capacity of IPv6 will enable supporting connectivity for a huge range of devices such as phones, laptops, IoT devices. And eventually, the enormous amount of IP addresses gives an opportunity of like to get rid of network addressing translation or NAT. And that means that every device has its own public address. IPv6 public addresses are more known as global unique addresses, and they're just the equivalent of public addresses in IPv4 networks. Global addresses are routable on the internet, but you may have questioned, does that mean that IPv6 has no private addressing? Well, as you can see, it doesn't. For example, in IPv4 internal addresses, these addresses use the reserved number ranges, and these addresses are not routed on the internet, and they are reserved for internal networks. IPv6 has 2 internal addresses, two types of internal addresses: link local and unique local. What about link local? These addresses are used to communicate between hosts on the same link. So that that they are used inside an internal network, and again they are not routed on the internet or even internal network. So they are restricted to a link. These addresses are self-assigned, and they do not. So that means they do not require any DHCP server on your network. And these addresses, as you can see, start with FE80 numbers with 64 subnet mask. Unique local. They actually also the internal private addresses. They used also inside an internal network. They are also not routed on the global internet, but they are routed on the internal network. So basically, they are equivalent to the internal IPv4 addresses. But nowadays, unique local are not yet commonly implemented as far as I know. So I mentioned that with IPv6, we don't need NAT anymore, but you may also have question, won't my network be less secure without NAT? But actually, translating addresses does not provide any security benefits because in many cases, NAT or network addressing translation require an outgoing connection to be present before they will allow an incoming connection. And this so-called stateful packet filtering can be enabled for IPv6 as well. So you may already be thinking, how can I use IPv6 to access internet personally? Is that even possible? Of course. First way to do that is just asking your internet service provider for IPv6. And for example, on World IPv6 Launch website, you can check providers that joined IPv6 launching and can provide you with IPv6 addresses. But what if you don't have a provider in your city or country that supports IPv6? Actually, that's not a problem because I don't have one, for example. There is a global internet provider called Hurricane Electric, and it can provide IPv6 as well. So you can just fill out the form on Tunnel Broker website and get yourself global IPv6 with 64 subnet mask and just for free. And what 64 subnet mask gives you? Well, it gives us an opportunity to have a subnet with that amount of addresses. I know that's impressive. But so now is the main question. With that amount of subnets and addresses that the person or organization can have with IPv6, is it even possible to make network reconnaissance in IPv6 networks? So at some point, yes. And in that part of my presentation, I want to show you some ways to do that. First of all, patterns. Actually, they're used in infrastructure networks to simplify the management, so it can be easy to remember the addresses and it can be easier to manage them. And first pattern, it can be low byte addresses in which most of the bytes are set to 0, except a significant one. Second is IPv6 based addresses. I know it looks weird, but that exists and we need to deal with that. And that addresses in which the IPv4 address is embedded in IPv6 address. The next pattern can be the service port addresses. It's actually basically like a low byte addresses, but instead of the significant last byte, we can use the number of TCP or UDP port of the main service that is running on the host. And we can use actually the word addresses, just embedded the word in the IPv6 address. But the word has its own limit because in hexadecimal there is usage only from A to F letters. So what about techniques? If we're talking about local network, the following techniques was found to be effective, and I'll cover a bit later local address scanning and traffic snooping or sniffing. On the other hand, if the target is a remote network, the following techniques may be used, and I'm going to describe in more details remote address scanning, DNS brute forcing, and DNS reverse mappings. So what about DNS brute forcing? Actually, it's the easiest one. Attackers may employ DNS brute forcing techniques just by looking for DNS quad A records against commonly used host names, and Nmap has an amazing feature called Nmap script engine. So you can just download the script that's called DNS brute from the official Nmap website and use it with Nmap to try yourself in DNS brute forcing. What is most interesting about this technique, DNS reverse mappings, is that it can greatly reduce the IPv6 address search space. Basically, an attacker walks through IP6 ARPA zone, DNS zone, corresponding to a target network, um, issuing queries for PTR records corresponding to the domain name. And if there were PTR records for any host starting with the domain name, the response would contain the code of 0 or no error, and otherwise the response would contain the code of 4. You can try PTR scan actually with Nmap too, and there is just another script called DNS IP6 ARPA scan. Or you can just use some web tools. For example, this is the reverse DNS tool from Network Tools. Address scanning, remote address scanning. Before remote address scanning, you should consider which subnet prefix to choose, because actually a typical site might have a 48 or 64 subnets to be scanned, and however, we can reduce the search space by guessing likely address plan schemes, or using any clues that might exist from your searches or from other sources or observations. And for example, there are a number of documents available online, like RFC 5375, that can provide some recommendations for the allocation of address space. And address plans might include addresses that, for example, run from low number upwards, use building numbers in hexadecimal or decimal form, and use even VLAN numbers. However, the scale of address scanning task is so large in IPv6, so that attackers must be very creative to be good enough. And simply sweeping an entire 64 subnet mask in IPv6 would just be impossible. There is a tool from IPv6 toolkit. It called Scan6, and it actually supports sweeping address ranges and can also use all the address patterns. So, and this tool actually can be found in default repositories on Debian-based systems. And I check only Debian ones. Sorry. What about local networks? Firstly, we can try to obtain information via traffic snooping or traffic sniffing. This can help in discovering active hosts in a number of ways. For example, firstly, each captured packet, of course, will reveal the source and destination of the packet. And secondly, the captured network traffic may correspond to network protocols that transfer information such as host or router addresses, network topology information, and so on. Local address scanning. IPv6 address scanning in local networks could be considered to some extent a completely different problem. The scanning a remote IPv6 network, and the main difference is that use of link local multicast addresses can actually relieve the attacker of searching for unicast addresses in large IPv6 address space. For example, an attacker can simply send probe packets to the all nodes link local multicast address and get a reply from all active hosts in a network. And this, but want to emphasize that this can help with discovering only link local addresses. Also, there are a variety of publicly available local IPv6 networks address scanners. And for example, even current versions of Nmap implement this functionality. And there is another toolkit called THC IPv6, and it contains a tool called Alive6 that implements this functionality too. And also, this toolkit can be found in repositories for Debian-based systems. What about mitigations? IPv6 address scanning attacks can be mitigated in a number of ways. For example, first that you can do is just to limit pattern addresses. The second, you can employ IPS system in your environment. You can enforce IPv6 packet filtering where it's possible. You can try to avoid use of sequentially addresses with your DHCP. And actually, ideally, that DHCP server would allocate random addresses from a large pool, and that's it. Actually, you can use what else that you can use is to use the default 64 size IPv6 subnet prefix just to make life harder for attackers. And in general, you can just avoid being predictable in the way addresses are assigned. What about block listing? IPv6 hosts are generally able to configure any number of IPv6 addresses within their 64 local subnet. And actually, in the event of malicious activity, you should block list at least the 64 subnet from which you may have detected malicious activity. And depending on the specific internet provider, the attacker might have control of prefixes of any length between 48 and 64. So if malicious activity persists after block listing the offending 64 subnet, you may want to block shorter prefixes. That means that you can block the larger blocks of addresses. Okay, so what else you should do or you should know while securing yourself or organization? Well, knowing the syntax makes it much easier to quickly know how to deal with a security breach, for example, or implement necessary measures. Shutting off IPv6 capabilities when you are not using it may seem obvious, but it may not be that easy because a number of programs have already been configured to work with IPv6, and just as many may already have the protocol turned on automatically by default. So what I mean that you need to check, double check, triple check your environment to ensure that IPv6 is enabled only when it is used. Even with large portions of network disabled for IPv6, there is still the threat of unwanted IPv6 visitors. And when that happens, organizations should know how to kill it before it can infect others in the network. And there is actually knowing the IPv6 address, IPv6 syntax can be useful, particularly for setting up effective firewalls and traffic filters. So my last question is, what continued IPv6 adoption means for internet security? Hackers actually tend to set their sights on new targets only when they become worthy of their attention. And the same goes for IPv6. As IPv6 adoption becomes more prevalent, threat actors are increasingly using its addresses as an attack vector. And for example, if threat intelligence feeds haven't prepared to analyze IPv6 addresses, they faced with big black holes in the data sets, and the ability and the main point here for me that the ability to monitor anomalous web traffic is actually a key to detecting a breach. So speaking of security, device producers should also be aware of IPv6 adoption, and this is especially true for IoT devices. The amount of internet-connected IoT devices grows exponentially, and millions of new IP addresses will be needed, and IPv6 will help with that, of course. But manufacturers should make sure that their devices are designed with the capabilities to support, analyze, and actually secure it. And in conclusion, I just want to say that IPv6 may have been a long time coming, but it's too late in the game to ignore. On that slide, you can see the links and tools that you might have missed, and also where you can find me. And I just want to add that in case of cybersecurity, if you are confused or you don't have a person you can contact, or you're unsure or embarrassed to contact someone, you can contact me without hesitation. I'm always glad to learn by helping people and resolving some interesting cases. And I'm ready for your questions.
Awesome. We do have a few questions.
Mm-hmm.
The first one being, well, relating to, of course, the adoption of IPv6 versus IPv4. Why do so many people still use IPv4 as a default, considering all of the security implementations of IPv6?
Well, the first reason is for me because people are just they just get used. They are used to use IPv4, and it looks easier to set up, and it looks easier, and it seems easier to, for example, have. It looks easier to like set your firewalls, because as I've already said that if we have a net, we can just set up a firewall on your router for one IP of like the outgoing IP. And with IPv6, it may be harder, because if you do not have like firewall on your router, it just means that you need to set up some security settings on each device that you have. Yeah, I hope I
Awesome.
answered.
Yeah. And then what tools are important to know for IPv6? Or IPv6, sorry.
Tools. Actually, if you set up in IPv6 like in your own environment or in your own device, it's not different from IPv4. So you just need to know how to set up a network on your device. It just did, and the main difference is just the numbers and the amount of the numbers, and that's all. Okay. But I want to add that, for example, if you want to implement the IPv6 from Hurricane Electrics, they have the instructors for implemented on your device. Nevertheless, like from your independently from your device that you use. For example, they have instructions for macOS, Windows, and for the routers with, for example, Cisco, iOS, or MikroTik.
Mm-hmm. Awesome. Well, considering that botnets exist across the internet nowadays, do you think it would be possible for botnets to adapt to using IPv6 scanning for mass host recruitment?
Oh, it's a quite hard action, is actually, because yeah, the amount of IPv6 addresses that could be implemented, that's really impressive, and it would be easier to set up botnets, of course, but I don't know. I never deep dived in the subject of like botnets with IPv6, but it's actually a very interesting question.
Mm-hmm. Great answer. And how do you combine NAT with IPv6? Was the final question?
Actually, NAT, it's not a requirement for IPv6, and when you have IPv6 you don't need a NAT at all. But there is a functionality that's called NAT64, and that doesn't mean that you can implement like private IP6, like make a NAT with private IPv6 addresses and public IPv6 addresses. NAT64 is actually designed for getting used to IPv6. So NAT64 is actually for translated your IPv4 address to IPv6, and it's actually quite like difficult technique, but it exists. Yeah.
Awesome. Thank you so much. You had such a
Thank
fantastic
you.
presentation. So thank you for being here with us.
And thank you. I was really enjoying the conference.
Yeah.
Thank you.
You've gotten a lot of positive feedback in the YouTube comments. So feel
Oh,
free to
that's
check
so
that out.
awesome. Thank you.
Yeah.